Hey everybody, it's Mr. Mott. What I want to do is go through how to balance oxidation reduction reactions using the oxidation number method. This is kind of our intro to our Chapter 20 electrochemistry unit. And electrochemistry involves the movement of electrons, which is super prevalent in our everyday lives as we're using our devices, our batteries, in our smartphones, our iPads, and our computers all the time. So first thing that we need to do in an equation like this is we're going to assign the oxidation numbers. So let's go ahead and do that. Hydrogen is normally +1, so we can go ahead and do that for all of our hydrogens. And then oxygens are usually -2 unless they're in a peroxide. And even though we have MnO2, this is manganese dioxide. This is not a peroxide. Very common mistake that people run into. All right. For all the other ones, what we need to do is we want to recognize that for our oxidation numbers, for a lot of the other elements, they change. And I forgot on the oxygen over there. So what we have to do is we have to figure out what that oxidation number would be. So what we need to do is kind of work that out. So taking a look at MnO4, for instance, the overall charge in this ion is -1. All of the oxidation numbers need to add up together and have an overall -1 to match the charge on the ion. The oxygens we know, we have 4 of them at -2, so we have a total of -8 from the oxygens. So we ask ourselves, what does Mn have to be so that that it adds up, everything adds up to a -1. So manganese then therefore must be a +7. Following some similar process, ClO2 minus has a -1 overall charge. 2 oxygens at -2 means it's a -4. So then the chlorine then, seeing what does chlorine have to equal? It has to equal +3. For MnO2, this has to add up to 0. We have a -4 from the two oxygens there. So manganese must be a +4 then. For ClO4 minus, -1. From the oxygens, 4 of them at -2 is -8. So chlorine then therefore must be a +7. Now to be clear, when I'm talking about the oxidation number, if I go back to our first MnO4 minus, the oxidation number is -2 on the oxygens. It just so happens that there's 4 of them in this compound, and that's where we come up with this -8 value. But this is me this is kind of my scratch work up here that I did above the equation. But the oxidation number of oxygen in this case is -2. All right, just kind of keep that in mind. Next, what we do is we look at what's changing, what's gaining or what's losing electrons. Well, MnO4 is going from +7 to +4. So that must mean, so you want to be thinking about this case is, does that mean it's gaining or losing electrons? Electrons being negative, it's going to have to gain, okay, it's going to have to gain 3 electrons, okay? Then when I look at if something is gaining electrons, I mean something else must have lost the electrons. So looking at the chlorine is going from +3 to +7. So this is actually losing 4 electrons. Okay. So what you have is that you have something that's gaining electrons, something that's losing electrons. Now, the electrons are not equal and they're not conserved according to how this equation is written because it's not balanced yet. So what we want to do is think about the least common multiple between 3 and 4, and that's going to be 12. So we're going to ask ourselves, in our first example, when we're dealing with manganese, if it's gaining 3 electrons, 3 times what gives me 12, and that's going to be 4. So what I'm going to do is I'm going to multiply my MnO4 minus by 4, and then also my MnO2 by 4. So then that means that we have 4 times 3, which is 12 electrons total are being gained. That means something else has to lose those. So then we look at what's happening with chlorine, it's losing 4 electrons. So 4 times 3 is going to give me 12. So I'm going to put a 3 in front of my Cl here and Cl here. Then it's just a matter of balancing everything else out. And what we've done really so far is really the hard part. So the last part would just be to balance out our hydrogens, things like that. And what it's going to work out to be is a 2 in front of the water and then a 4 in front of the hydroxide on the product side. All right. So that's how you balance the balance redox equations using the oxidation number method. Really important to know here is that you can only balance according to the oxidation number method when the reaction is complete. Okay, so the reaction must be complete for you to do this. Okay, if there are things that are missing in the equation, which we're going to encounter in our other methods, then we would be able to use the oxidation number method. And probably what's going to happen on the AP exam and on our exam is that you would be required to be able to demonstrate that you could balance it in one method versus the other. All right. Thanks for watching.